So I think the best way to really explain this is actually to see a student using it for real. So what Manuela has done here is, first of all, she's generated the full set of reagents that are necessary. So there's the cells, the three different plasmids, the 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 heat shock mix, the lysogeny broth, and some water. And the next thing she's doing is generating a couple of racks, which she's going to adjust one of the racks to 37 degrees, because that's going to be the rack that she transfers tubes to get some incubation, both for the heat shock and later on for the recovery. So she makes some blank tubes, and notice how diligent she's been in labeling them. I must admit that when I do things like this, I don't put as much effort into labeling. And she's putting each of the plasmids into P1, P2, and P3, and the milli-Q water into the negative control. And now she's putting the KCM mixture and the cells into those tubes, and that means that now these tubes are ready for the heat shock. But notice as well that she's mixing, and she's mixing by double, triple, quadruple pipetting up and down. And then she goes for mixing with the top as well, which, so it's absolutely no question that these tubes are going to be mixed. She now incubates the tubes, which basically just means leaving them there for 10 minutes, and then transfers them to the rack for the real incubation, which is going to be something that she takes, I think, about half an hour on, I don't know, 20 minutes or so. And it's very interesting to note how careful she's being about the timing. So very disciplined with using that time dilator, but at the same time, really making sure that she doesn't go over. So, great forward planning and execution. So now what's happening is that the lysogeny broth is being put in each one, and that will make the cells happy again. So after mixing and transferring the tubes to the 37-degree block, now there'll be basically the cells are going to come back to life. So at this stage, what Manuela does is she lays out a whole bunch of plates, and these plates are each impregnated with a different antibiotic. So the first set of 4 didn't have any. Then we've got ampicillin, chloramphenicol, and the final set of 4 plates that she'll lay out in this lovely grid is the kanamycin. So she's got now the ability to pipette each of these 4 samples onto each of these 4 sets of plates, and she's basically going to put 70 microliters of each onto each of the plates. So just pipetting those on, putting the lids down, and then after the bacteria have been put on the plates, they can go into the oven straight away, but she's actually going to finish the whole grid. And I mean, the other thing I just love about what she's doing is using the camera to facilitate her view. So she zooms in when she needs to, she zooms out when she needs to. Now this bit here with the camera only putting half of the plates in, so is my fault for not making enough spots in the oven. I mean, it's a purely arbitrary number that can go in the oven. They're only virtually going in there. So I really should have made it so that at least 16 could go in. Now again, look at the really diligent use of the time. So she's extended time. It's all happened very quickly, but the plates have come out, and now she's going to put the next set of 8 plates in. Again, I'm feeling sheepish here that I didn't make more room. Again, look at the brilliant use of the camera, and the fastidious use of the time dilator. And now we get more good use of the camera to observe what comes out at the end. And lifting the lid on these and is really a great way to see what's underneath. Very, very clear that colonies have formed in these plates here where there's been no selection, and these colonies are whatever bugs, any bug will grow on those. But then, of course, with these selective plates, we've got only things growing, the green things growing on the ampicillin resistant plates, the red ones growing on the chloramphenicol plates, and the yellow ones growing on the kanamycin plates. and nothing growing on the antibiotic impregnated plates when just water was used instead of plasmid. So totally perfect results, a brilliantly choreographed and organized set of additions, amazing discipline with the timing, just absolutely brilliant stuff. So that's the way that that particular practical works. It really does require the students to adhere very strongly to the instructions and to have really good planning. And they will get, of course, results that are commensurate with their actions. If they miss out any of those steps, if they put too much or too little in at any stage, they get the temperatures wrong for the incubation, they do the wrong timing for the oven. It's all going to affect the readout that they get, the number of colonies and the type of transformations that might occur. So again, with everything else, you can make it so that you give different students different plasmids. They might have access to different plates. There's just so many ways that you can um, change this up and give each student a unique context and end result whilst keeping the overall strategic aims the same.